Hey class, here we are in our Chapter 5 lecture, Sleep, Dreaming, and Consciousness. Hopefully this has been a fun chapter for you to read about. I think it's really interesting stuff, so I hope you found the same thing. Also this week, just take note, there's no discussion post due, so just enjoy the videos that I've put up for you to see and do this lecture and your reading and your quiz, and don't worry about a discussion. Okay, so the first thing to talk about is our biological rhythms, which are natural variations in biological functions, hormonal activity, temperature, and sleep that typically cycle every 24 to 25 hours. So this is also called circadian rhythms. The term circadian comes from circa, meaning revolving, and dia, meaning day. So that's where that comes from. And if a cycle is approximately annual, such as a growth cycle in some plants, it's called a circumannual cycle. Again, circa meaning about and annual meaning year. So just a little definition there for you. Okay, so the next thing to talk about here when we're talking about circadian rhythms a little bit more is how that exactly is going on inside of you internally. How is that biological clock actually ticking? So this is controlled by the suprachiasmatic nucleus, which is an area of the hypothalamus that is located above the optic chiasma, which is the point at which the optic tracts from each eye intersect. So this location easily allows the SCN to monitor the activity of the visual system. And the SCN exerts the main control over biological rhythms and is also referred to as the biological clock because damage to this area disrupts daily cycles in sleep and other biological functions. Okay, looking here at figure 1, this is talking about the way that activity in rats changed depending on how the light in the room was set up. So let's go ahead and look at figure A. And here we see the dark phase is from 7 p.m. to 7 a.m. In part B, the dark phase was shifted from 1 a.m. to 1 p.m. And notice how the activity shifts very quickly here between these two to fit into the activity of light there. Then we see under constant illumination in part C, the activity becomes free running. So in both rats and people, the free running clock runs about 1 hour slow each day. And this is illustrated by the advancement of wheel running by about 1 hour each 24 hours. When there is no day-night schedule and light is continually on, the activity of rats and people becomes free running, which means that the activity cycles are no longer under the control of the light schedule, but rather on the animal's biological clock. And interestingly enough, most biological clocks are not adjusted to 24-hour cycles. So as you can see in figure 5.1c, the animal's clock runs about 1 hour slow each day. So that's interesting. And people exhibit circadian rhythms of activity as well. We normally begin to feel less active several hours after the onset of the dark part of our day-night cycle, and most alert several hours after light onset. As with other animals without a light-dark schedule, we adjust to a 25-hour free-running clock. So that's what this figure is illustrating. Okay, so the science of sleep and dreaming. First of all, let's just start with the definition of sleep. Sleep is a natural, periodically occurring state of rest characterized by reduced activity, lessened responsiveness to stimuli, and distinctive patterns of brain activity. There's two different types of sleep, and this came about in the early 1950s when Eugene Aserinsky, who was a graduate student at the University of Chicago, observed systematic changes in eye movement of sleeping infants. He noted periods of sleep which the eyes moved rapidly, followed by intervals of little or no eye movement. So REM sleep is rapid eye movement, state of sleep characterized by rapid eye movements and often associated with dreaming. And then we have non-REM sleep, which stages of sleep during which rapid eye movements typically do not occur. So very interesting, dreaming occurs far less frequently during NREM, non-REM sleep than during REM sleep. Dreaming is not limited to REM sleep, however, and REM sleep is not synonymous with dreaming. People awakened during REM sleep do not always report dreams, and likewise, people awakened from non-REM sleep sometimes report having some kind of mental activity, such as a vague recall of some event, although not consistently labeling such activities dreaming. So for this reason, it is difficult to estimate the exact proportion of non-REM dreaming to REM dreaming. There is widespread agreement among sleep research that non-REM sleep is considerably more dream-free than REM sleep, and that dreams reported during REM sleep are usually much more vivid, tend to last longer, and are more visual than the thought-like processes that occur during non-REM sleep. So let's just talk a little bit more before we talk about this. Let's talk a little bit more. Let's go back to that last slide. Oops. About let's talk a little bit more about these stages of sleep. Okay, so although there's a clear connection between REM sleep and dreaming, rapid eye movements have little, if anything, to do with dream content. So even people who have been blind for over 50 years and cats raised in the dark who have never seen anything still show rapid eye movements during sleep. So that's an interesting thing to think about. This is really important too. During REM sleep, skeletal muscle activity is greatly suppressed, leaving us relatively paralyzed. And so our eyes are twitching a lot, right? Rapid eye movement is happening, but basically the rest of your body is pretty much paralyzed. So what's interesting then is that when we think about what stage of sleep things like sleepwalking, sleep talking, or sleep terrors are occurring, we would think that that would have something to do with REM sleep because that's when your brain appears to be really active, you're having these dreams, your eyes are rapidly moving. However, when we are dreaming, our sympathetic nervous system causes an increase in breathing and heart rate, as well as an elevation of blood pressure. And the only part of the body moving vigorously is the eyes. So sleepwalking and sleep terrors are almost invariably occurring during non-REM sleep. And one study of cats demonstrated the link between the pons and the loss of muscle tone during dreaming. When researchers destroyed a small portion of the region of the pons that produces atonia, cats became very active during REM sleep. So very interesting. So although you're dreaming and your eyes are rapidly moving, basically everything else is paralyzed. There have been cases, though, where sometimes with some humans, when they enter REM sleep, they don't seem to have this paralyzing effect on the rest of their body, and they can thrash violently about, leap out of bed, and may even attack their bed partners, depending on what they're dreaming about. And in one case, a husband awoke to find that he attacked and killed his wife while they both slept. And his defense was that he recalled that he was being attacked. So, interesting, there's now a disorder called REM behavior disorder. Okay, so now let's talk a little bit about how we are measuring the stages of sleep. So we have an electroencephalogram, which is an EEG, and that measures brain waves. An electrooculogram, which measures movements of the eye. An electromyograph, an EMG, measures electrical activity in the muscles. So here we see an electrooculogram recording of eye movements. And you can see the different stages of sleep here, a great deal of activity, and then not as much. So this is when you're going back and forth between REM and non-REM cycles. So characteristics of waking and sleep cycles. When we are awake and alert, the EEG reveals low amplitude, high frequency waves called beta waves. When we are relaxed and drowsy just before falling asleep, our brain waves show an alpha rhythm of higher amplitude and slower frequency. So breathing and heart rate slow down, body temperature drops, and muscles relax. Stages of sleep. We have 4 stages of sleep, and the first stage is the light sleep that occurs just after dozing off and is characterized by brain waves called theta waves. Some slow eye movements, irregular breathing, and muscle relaxation may accompany stage 1. People are easily awakened and often do not realize they have been sleeping. This stage usually lasts from about 1 to 10 minutes. Then we have stage 2, which typically follows stage 1, surprise, surprise, and is characterized by brief bursts of brain activity called sleep spindles, as well as K-complex responses to stimuli, such as noises. Eye movements are minimal during stage 2, and muscular activity often decreases to an even lower level. Stage 3 sleep typically follows stage 2 and is characterized by an EEG tracing, 20% to 50% of which consists of delta waves, virtually no eye movements during stage 3 sleep. And then we move into stage 4. This is the deepest level of sleep and characterized by an EEG tracing exceeding 50% delta waves and virtually no eye movements. Okay, so here's a look at what is going on there in your brain, what the waves are looking like as you're awake. Up here we have beta waves, low amplitude, high frequency. Then we have, once you're getting drowsy, the alpha waves with a higher amplitude and lower frequency. And then in non-REM sleep stages, here we have stage 1, theta waves, low amplitude, low frequency. Stage 2, sleep spindles and the K-complex. So here's a sleep spindle, and here's the K-complex. Stage 3 sleep, beginning of delta waves, low amplitude, high frequency. And stage 4 sleep, delta waves continue to increase in proportion to other waves. Okay, and then REM sleep comes in after we've gone through all of these stages and re-enter stage 1, about 90 minutes after falling asleep, frequently called emergent stage 1 or stage 1 REM sleep. In REM sleep, brainwave patterns are very similar to those of initial non-REM stage 1. So here we have REM sleep brainwaves, and then if we look back up here, you can see that that looks pretty similar to this. So it takes roughly 45 minutes to reach stage 4 of sleep after first dozing off, and we remain in stage 4 for about 30 to 40 minutes, then gradually return through stages 3 and 2 to 1, about 90 minutes after falling asleep. During the night, we move through successive cycles between the various phases of REM and non-REM sleep, and REM episodes become longer throughout the night. Interestingly enough, there are some pretty significant changes in the sleep patterns with age. So newborns sleep 16 hours a day with 50% of the time spent in REM sleep. Adults in their 20s sleep about 8 hours with 20% of the time in REM sleep. And then there's further decline in sleep and the percent time in REM sleep during middle age. And between the ages of 60 and 70, a person may sleep only about 6 hours with 15% spent in REM sleep. And stage 4 sleep may disappear altogether by our 60s. So as a consequence of this, older people are more easily awakened, and it's not uncommon for people who were sound sleepers throughout most of their lives to now be waking up multiple times throughout the night. Let's go back to here to figure 5.5. This is an interesting graph. Sorry. This is the one I wanted, 5.4. This is going to show you pretty clearly what's happening, how these stages are working. So here we're alert, and then we're descending down into the stages of sleep. hitting stage 4 sleep, and then cycling back out of it. And then once we get back to stage 1 is when we hit our first REM cycle. Okay, and then we start cycling back through the stages, and again reversing out of them, and then REM cycle. So here's a graph of what non-REM and REM cycles are looking like. And here is a great graph about how many hours of sleep different animals have. So you can see here bats sleep a lot, not that surprising, live in the dark. Cats also pretty high up there on the list, which I can understand given that I have cats and they sleep all the time. Then we have a rhesus monkey who's pretty close to us. Again, probably no surprise there. Pretty similar biologies. And then also, not too surprising, a cow and a horse are not that dissimilar because both prey animals and not sleeping as much, likely due to needing to be biologically awake and alert in case of predation. Okay, so let's talk a little bit about brain mechanisms of sleep. So the reticular activating system is a set of neural circuits extending from the lower brain up to the thalamus that plays a critical role in controlling arousal and alertness. This is also known as reticular formation, and the primary transmitter of this circuitry is norepinephrine. And then we have the raphe nucleus, which is a group of serotonin-containing neurons extending from the raphe nuclei, located in the pons and medulla, throughout the system and forebrain. Serotonin neurons in this region of the raphe nucleus originate between the reticular activating system in the brainstem and ascend through the pons and the medulla to the midbrain. The raphe nucleus becomes most active at the time of sleep onset. This increase in raphe activity acts to inhibit the RAS, thus decreasing arousal and promoting sleep onset. Let's talk just a little bit more here about the neurotransmitters of arousal and sleep. So the primary neurotransmitter of the RAS is norepinephrine, as I just said. So drugs that increase the activity of these norepinephrine neurons, such as amphetamine, increase alertness and arousal. And during the waking part of your day, your RAS is quite active, filtering the constant array of stimuli entering your sensory systems and thereby allowing you to attend to specific events. Likewise, acetylcholine neurons, originating in the basal forebrain, activate cortical structures that are essential to ongoing behavior and thought process. So the essential neurotransmitters of arousal are norepinephrine and acetylcholine. On the other hand, serotonin and androstenedione appear to be the neurotransmitters of sleep. Research has shown that destruction of the raphe nucleus or disruption of serotonin synthesis results in insomnia. Restoring serotonin can reverse both of these effects. And then one other hormone implicated in the sleep-wake cycle is melatonin. This is produced by the pineal gland during the dark phase of the light-dark cycle. Its production is inhibited by light, and some research suggests that taking melatonin several hours before a desired sleep time can promote sleep onset. So sleep deprivation studies. Let's talk about these a little bit. So in a widely reported personal experiment, there was a disc jockey, a DJ in New York named Peter Tripp, and he staged a wake-a-thon and stayed awake for 200 hours. Halfway through his wake-a-thon, he began to hallucinate. His ability to think and reason deteriorated dramatically, and by the end of his ordeal, he was unable to distinguish between fact and fantasy. And also, he became increasingly paranoid. So this sort of brought up, this idea of what happens to people when they don't sleep. So then several subsequent studies were carefully done and controlled because this Peter Tripp, was not a very scientifically controlled study. However, some other ones, one done in 1970 by Kales, 6 volunteers were deprived of sleep for 205 consecutive hours. By the end of the 3rd day, subjects were hallucinating and experiencing delusions. They also developed hand tremors, double vision, and reduced pain thresholds. Their reflexes were largely unimpaired, however, and physiological functions such as heart rate, respiration, blood pressure, and body temperature showed little change from normal throughout the course of the experiment. The next one we're going to talk about is the University of Chicago Sleep Research Laboratory experiment in which rats were used, and rats were studied in pairs. One was deprived of sleep and the other acted as a control. Both of these rats were placed on a plastic disc located above a water pan. If the disc rotated, the rats had to walk to avoid falling into the water. The rats were connected to an EEG that monitored brainwaves. Whenever the sleep-deprived rat fell asleep, the EEG registered the changes and opened a circuit, causing the disc to rotate. Both rats would have had to walk to avoid falling in the water. The control rat could sleep whenever his counterpart was awake, but the sleep-deprived rat was jarred awake at each lapse of consciousness. The sleep-deprived rats lasted as long as 33 days, but they all eventually died. In contrast, the one that could sleep, the control animals, all survived. In each of these experiments, the University of Chicago scientists were unable to determine the precise cause of death. A variety of sleep deprivation effects were observed prior to death, including a progressively scrawny appearance, skin ulcers, increased food intake, weight loss, an increase in energy expenditure, a decrease in body temperature, and shifts in levels of the hormones norepinephrine and thyroxine. So the studies that have been done on people with sleep deprivation haven't produced the same fatal results necessarily in humans, but there is a rare neurological disorder called fatal familial insomnia, which results in damage to the regions of the thalamus and suggests that severe sleep deprivation in humans could also be fatal. Okay, so here we have major brain areas involved in sleep and arousal. Here's the Raphe system, the Raphe nuclei, and here's the RAS. And here we have a little diagram of what this experiment with the rats looked like. So you can see that they had to keep moving or else they would have fallen in the water. So interestingly enough, from the studies that we've just looked at, and probably from your own experiences, it seems that sleep is necessary, but we aren't really sure why it's necessary. So here are some different theories trying to explain why maybe we need to sleep. So sleeping to conserve energy. We use less energy when asleep, pretty clear there. Sleeping to avoid predation. Prehistoric man avoided predators by sleeping at night. Sleeping for restoration, restoration of cell damage, neurotransmitters, and promotes tissue growth. And sleeping for memory. It aids in memory consolidation. Likewise, it's not really understood why we dream. Oops, excuse me. Let's back up there. Okay, not really understood why we dream. So what is the main function of dreaming? How many times per night do we dream? Is the content significant? Do animals dream? And what happens when people are permitted to sleep but not to dream? So we have some experiments here that are going to help us maybe start to answer these questions. The first is a REM deprivation study. William Dement studied the questions that we just went over before, and in 1960 he used both an EEG and an EOG to register the beginning of REM sleep. For 7 consecutive nights, he would allow subjects to sleep, but awaken them when they began to enter REM sleep. REM-deprived subjects became increasingly irritable, anxious, hostile, and aggressive. And they experienced REM immediately as the study progressed. REM rebound occurred. So such results have been interpreted as supporting the theory that we sleep to dream, and some psychologists have cited these findings as evidence that REM deprivation can produce severe emotional consequences. And again, let's go back to rats here. In one study, rats were placed on tiny platforms over water where the only possible way to sleep was standing. So the rats were able to experience non-REM sleep because their muscle tone allowed them to sleep standing up. Recall, however, that muscle tone is lost when REM begins. Thus, whenever REM sleep began, the rat's legs would collapse, toppling it into the water. What happened to these rats? Contrary to what you might expect, the REM-deprived rats did not show any significant behavioral or emotional difficulties. However, other research has reported quite different results. Again, back at the University of Chicago Sleep Lab, 12 rats were deprived of REM sleep using a rotating platform apparatus similar to the, excuse me, my computer's having a moment. Okay. Similar to the one that we looked at before, the figure of the rotating table there. And in contrast, a paired control group of rats was permitted to sleep during any of the 4 stages, while the rats in the control group survived with no sign of debilitation. All 12 rats assigned to the REM deprivation condition died. So these physiological changes have been observed in other studies. They include death, deteriorated appearance, skin lesions, weight loss, increased energy expenditure, and decreased body temperature. Not surprisingly, we haven't tried this on humans. But, you know, looking at these results with rats, it's likely that it wouldn't be very healthy for people to not have any REM sleep. Okay, animals dreaming. Yes, the fact is that REM sleep has been recorded in all mammals, as well as in several species of birds, and there is good evidence that REM sleep in animals corresponds with dreaming. So that's interesting. And then let's talk a little bit here about dreams as expressions of the unconscious. This would be going back to Freud, who we talked a little bit about in our earlier chapters. And he believed that symbolic processes that represent wishes or desires that become fulfilled by the dream code, the content of a dream. So our unconscious protects us by using symbolic representations of our deep-seated wishes. So basically what this is saying is that the meaning of the dream is the latent content or the hidden content, okay? And the manifest content is the disguised version of the latent content. So basically what Freud is saying is that our brains are protecting us from being shocked and appalled by our deepest desires, deepest, darkest desires, by sort of masking these with symbols and dreams. So Freud saw dreams as a mechanism to discharge libidinous energy stored in the id. And the id, according to Freud, is the biological component of personality consisting of life and death instincts. During wakefulness, the expression of the id's wishes are constrained by the superego, an individual's conscious. However, during dreaming, the wishes of the id are left unrestrained and may be expressed symbolically. Again, like we talked about earlier with Freud, none of this can be proven. So here we are back at Freud and the symbolism, similar to his psychodynamic theories. Hard to prove that, but still has really influenced the field of psychology and how we think about dreams and interpreting them. So there are some disorders of sleep that we're going to talk about. A sleep disorder is a class of disorder that interferes with sleep and includes insomnia, sleep apnea, sleep terrors, nightmares, and sleepwalking. So first of all, insomnia is a sleep disorder characterized by a consistent inability to get to sleep or by frequent awakenings during sleep. 15% of adults suffer with chronic insomnia, and 35% of adults suffer from occasional insomnia, which is temporary or situational. So temporary or situational insomnia is directly related to stress associated with a particular situation. So loss of a job, death or illness of a loved one, a relationship that falls apart, school, grades, work, all of that stuff. Chronic insomnia is long-lasting sleep loss, and these people are more likely to report a serious erosion of the quality of their lives. And we are still not sure what causes chronic insomnia, although it does seem to be associated with anxiety or depression. Sleep apnea is a sleep disorder characterized by irregular breathing during sleep. This person is unlikely to be aware of this condition and requires a sleep study to confirm a diagnosis. What sleep apnea is people with this disorder do not breathe regularly during sleep, and their breathing can actually stop for as long as a few seconds to a minute or two. Then, as the need for oxygen becomes acute, the person briefly awakens, gulps in air, and settles back to sleep, only to repeat the cycle when breathing stops again. A person with this disorder is unlikely to be aware that he or she wakes up to breathe as often as several hundred times a night. And sleep apnea seems to occur when the brain stops sending signals that trigger the breathing response. It also can be caused by a blockage in the upper air passage. And some research believe that sleep apnea could be a cause of sudden infant death syndrome. CPAP is often the treatment of choice. So this is wearing basically an oxygen mask to sleep and having a constant flow of oxygen. Did I skip a thing here? Oh, I just went too fast. Okay, then we have narcolepsy. This is a sleep disorder characterized by falling asleep suddenly and uncontrollably. This involves the immediate onset of REM sleep and can endanger a person's life, as you can imagine if someone with narcolepsy is driving a car, for instance, and they fall asleep suddenly, that could be very dangerous. We still don't know why narcolepsy occurs. Although there is some theory that it's connected to stress. Okay, then we're going to talk about nightmares a little bit. So nightmare is a bad dream that occurs during REM sleep. Usually they leave a pretty strong impression, and people usually wake up with a vivid recall of the dream. Sometimes nightmares can be repetitive. Used to be thought that repetitive nightmares reflected areas of conflict or sources of emotional turmoil, but recent research suggests that there is a strong genetic contribution to the occurrence of nightmares, which tend to run in families, greater prevalence in females. Nightmares also tend to occur throughout one's life and are frequently associated with psychiatric disorders. Often there's confusion between nightmares and sleep terrors. A sleep terror is a sleep disorder in which a person suddenly awakens from stage 4 sleep in a panic, typically with no recollection of a bad dream. So this is happening in non-REM sleep, a sleep terror. Sleep terrors may occur with a piercing scream or a cry out for help. The sleeper can sit up, stare unseeingly, and perhaps gasp or hyperventilate. Occasionally, the sleeper jumps out of bed. Fully awakening doesn't always occur following a sleep terror, and people awakened by a sleep terror usually recall a sense of fear, but not the content. These sleep terrors seem to be directly related to daytime stress and fatigue. Okay, sleepwalking. This occurs in stage 3 or 4 of non-REM sleep when the body is capable of movement, obviously, right? Wouldn't be able to walk in REM sleep when you're basically paralyzed. And the duration of sleepwalking can vary from a few minutes to over half an hour. It's virtually impossible to wake someone up who's sleepwalking. And don't worry though, contrary to popular belief, you're not going to kill someone from waking them up from sleepwalking. Sleep talking is the production of speech or speech sounds associated with sleep without subjective awareness. And this is not considered a symptom of any underlying disorder or of any clinical significance. Most people at some point in their life are going to mumble something in their sleep. Okay, hypnosis. Very fascinating. Hypnosis is a phenomenon that is a state of altered consciousness characterized by deep relaxation, detachment, as well as heightened suggestibility to the hypnotist's directives. Has been used to improve athletic performance, relief of physical ailments, pain relief, and memory enhancement. Interestingly enough, with the use of EEG recordings, in the state of hypnosis, it's a very different state than being asleep. And hypnosis has also been shown to have some really beneficial aspects. So there's no evidence that hypnosis can increase a person's capacity to perform beyond natural limits, but it can act as a powerful motivator. So when we're talking about improving athletic performance, we're talking more about motivation. Well-documented evidence shows that suggestions given to hypnotized people can help relieve the symptoms of a variety of stress-related illnesses, including asthma, ulcers, and colitis. Pain relief. Most medical practitioners today acknowledge that hypnosis can be very effective in reducing the pain associated with childbirth, back problems, arthritis, dental procedures, burns, and even major surgery. One early study found that hypnosis was more effective than aspirin, acupuncture, or morphine in reducing pain. And then memory enhancement. There's little substance to claims that it can enhance a person's recall of a criminal act, but it may well be that, hypnosis can plant false memories in. So sort of the suggestion of something happening when a person is hypnotized can actually be why they feel like they remember it. A post-hypnotic suggestion is something that motivates people to perform a variety of actions after they return to a normal state of consciousness. There is a common misconception that hypnosis cannot be used to motivate behavior in which a person would not ordinarily engage. It is true that most hypnotized people would not comply with direct suggestions to behave in an antisocial or inappropriate way. However, a hypnotist can alter the perceptions or awareness of a susceptible subject in such a way that such behaviors seem necessary or appropriate. So why does hypnosis happen? We have a couple theories here. First one is dissociation theory. This is a theory of hypnosis proposed by Hilgard, in which our behaviors become separated or dissociated from our awareness. And then another is hypnotic suggestibility. This is the predisposition to attend to a hypnotist's suggestion. Consciousness is a sense of self in the world around us. Sensory neglect is a lack of awareness of our attention to stimuli on one side of the body when damage has occurred to the opposite side. Parietal lobe. Free will is the assertion that our choices and actions are not caused by antecedent events, but emerge spontaneously from the mind. Antonio Damasio, a neurologist and a neuroscientist, has proposed a definition of consciousness as the special features that exist in the mind that permit us to know that we ourselves exist and that things around us exist. In other words, having a sense of self and the world around us. Any definition of conscious must contain both a reference to our awareness of self our feelings and our memories, as well as a reference to our awareness that things outside of us exist. Okay, and that's all for our lecture for chapter 5. So hopefully that was helpful, and sort of a shorter chapter this week, which is nice. So I did put up a lot of videos for you to maybe balance that out a little bit, and because you don't have a discussion post. So this week you're mostly just watching things and doing your quiz, and then we'll be back to our discussion post next week. So everybody have a really great week and get some sleep.